Welcome in the next lecture of several variable calculus. In the previous lecture, we discussed the differentiability of a two variable function. Also, we defined differentials, then linear approximation and linear function. In the today's session, we have to discuss all these concepts for functions of three or more variables. So, we start our today's topic, that is the functions of three or more variable, and in this we have to discuss one by one the differentiability, then we have to discuss the linear function, or we can say linearization, and then we have to discuss here linear approximation, and then we have to take differentials. All these concepts we have to discuss for three or more variables. First we write three variable, and you can extend it for the more variables. Okay, so we will go for one by one. Let w is equal to f of x, y, z be a function of three variable. Okay, then what we have to write? First definition, we have to write differentiability. If the function f is differentiable at ABC, at point ABC, if delta omega can be written in the form what? Delta omega is equal to. How we write? Think the definition of our two variables. Similar definition we have to write. What we have to take? Fx at ABC, and here what we are taking? Delta x plus fy at ABC into what? Delta y plus fz at ABC. What we can write? Delta z plus what we have to write? Epsilon 1 delta x plus epsilon 2 delta y plus epsilon 3 delta z. Where what we are written? Where epsilon 1, epsilon 2 and epsilon 3 tends to 0, as delta x, delta y, delta z tends to 0, 0, 0. Okay, so this is the definition of a differentiability of a function f at point ABC. Okay, so in the next we can write the linear function or linearization is linear function. What we can write? Linear function, how we write this? That is linear function denoted by f of x, y, z, and it is equal to what we have to write? F of a, b, c plus what? Fx. What we can write? At point ABC, and into what? X minus a plus fy ABC at into y minus b plus what you can write? fz ABC into z minus c. Also we can write the definition for the linear approximation. then the linear approximation is linear approximation. Just we have to write, instead of L of x y z, we have to write f of x y z and the approximation sign, and you have to write all RHS as it is. So this is the linear approximation x minus a plus fy abc y minus b plus fz abc at z minus we can write. So we written already 3 definition. Then what change in? Then we write 4th definition. The increment in omega is delta omega, defined as, how we define this? Delta omega is equal to, how we write this? Delta omega, it is equal to what? F of a plus delta x, b plus delta y, c plus delta z minus f of a, b, c. This is the increment in delta w. And then the differential dw in terms of differentials what? Dx, dy, dz defined as what? How we defined as differential dw in terms of differential dx, dy, dz is defined as what we can write here? dw is equal to dA bar w by dA bar x dx plus dA bar w by dA bar y dy plus dA bar w by dA bar z dz. And then we can write the 6th definition. Then the linear approximation in terms of differentials is what we can write? Linear approximation, instead of this, all these, this is nothing but our differential dw, so you can replace this, that is you can write this linear approximation. How we write this linear approximation? F of ABC plus dw, you can write this. Okay, so we discuss up, we wrote all the definition of the function of 3 or more variable. Okay, so we take one problem. So we solve one problem on a differential. So what first example we are written here? The dimension of a rectangular box. So what we have? Dimension of a rectangular box are measured to 75 centimeter, 60 centimeter and 40 centimeter. Each measurement is correct within 0.2 centimeter. Is it? Use differential to estimate the largest possible error. So what we have to find? Largest possible error when the volume of the box is calculated from this measurement. That is, you have given one box, we have a given dimension, and in the measurement of dimension there will be error of a maximum error is 0.2, and then we have to find the error in the measurement of the volume of the box. Okay, so what is the error in the volume if this dimension we use, and for this we have to use the differential. So how we write? Solution first. Let x, y, z be the dimension of the rectangular box. Hence, the volume V is, then what is the formula for volume of the rectangular box? It is LBH. Length into height into base. That means here is our XYZ. Here is our XYZ. So this is our function. Now what we have to find? Now this here V is a, what we can write? Where V is a function, that is V is capital V is a function of three variables x, y and z. It is a function of three variables. Therefore we have to use the definition of differential dv. So then the differential dv is, so what is the differential dv? dv is equal to, what we can write? Dabba v by dabba x dx plus dabba v by dabba y dy plus dabba v by dabba z dz. Now we are not going to find separately the partial derivatives. You can find directly here. What is dabba v by dabba x? That is derivative of v with respect to x. That is derivative of x is 1. So we only yz dx. So similarly here dabba v by dabba y, derivative of v with respect to y is 1 into xz. So xz dy plus dabba v by dabba z, similarly it is xy dz. So it should be our dv. So this is our dv we find. Is it? Now we have a given a dimensions. So what we have given? We have given that. So what we have given that? X is equal to 75 centimeter, y is equal to 60 centimeter and z is equal to 40 centimeter. Is it? Dimensions you have given and a maximum error is given. The maximum error in measurement of dimension x, y, z is 0.2 centimeter. Is it? We have given error is 0.2 centimeter. Therefore what we can write? Mod of dx is less than or equal to 0.2, mod of dy is less than or equal to 0.2 and mod of dz is less than or equal to 0.2. You can, that means error may be less, but what is the maximum error? We have to find the maximum error in that is, we have to estimate the largest possible error when the volume of the box is calculated from this measurement. We have to find largest possible error. Therefore, we take a largest value. For largest possible error, we take, what we have to take? Dx is equal to 0.2, dy is equal to 0.2 and dz is equal to 0.2. Now just put all this value in equation number 2, do calculation, you will get the answer. So from equation 2, what we are getting? dv is equal to, what is the value of y? Value of y is 60 into what? 60 into 40 into what? 0.2 plus what we can write? X into z. X means 75, y means x, z means 40, it is again 0.2 plus what is third? that is the x means what? Our 75, and then here is a y means what? Here is a 60, say, into what? 0.2. Okay, so you can do calculation. dv is equal to what? What you can write here? 60 as it is. I am writing 40 into 2, 80 point, that means 8.0. You can write it is 8.0 plus 75 we are written as it is 40 into 2, again 40 into 2, it is 8.0. Again here we are keeping what? 75 as it is, and just I am 6 into 2 is 12, so 120 will be the answer, and then we are taking here point, then it should be 12. Okay, so now we have to just do calculations of 6 8s are 48, 480 plus 8 5s are 40, then 7 8s are 42, 56 plus 5, 4, it is 60, plus what we can write? 12 5s are 60, then 12 7s are 84 plus 6, it should be 86, 84 plus 6 is 90. So what we can write here? This should be 0, then it should be 8, then 15, 9. So 980 centimeter cube. So maximum possible error is 1980 centimeter cube. Okay, therefore you can write the maximum or largest error is 1980 centimeter cube. It is in centimeter, therefore you are thinking it is very high, but it is not that much high. It is just 1% error in a rectangular box. Okay, so in the similar way we can find the error by using the differential. Okay, so we can solve so many problems like this. Similar problem we will take, it is in practical session. Thank you very much.